In this precalculus algebra video, we're going to learn how to determine when functions are one-to-one. So first, a definition. A function f is said to be one-to-one if no two elements in its domain have the same image. And we write this mathematically as follows. So in other words, if whenever you have two elements in the domain x1 and x2 that are not the same, what does that mean? Well, it means that they can't have the same image. So any two elements that are different for this function, that implies they get mapped to different elements. F of x1 is not equal to f at x2. So two different elements, that means that their images, that is, their values under the functions or under the function is different. Now this is written in the same way, or in a logically equivalent way. So, or if the images are the same, so if you have a situation where f at x1 is equal to f at x2, what does that imply about x1 and x2? Then x1 must be equal to x2. That is, the only way two images are the same is if the underlying elements in the domain were the same. Okay, and now it's this latter equivalent definition that we usually use to determine whether a function is one-to-one. So for example, let's say you want to determine whether f of x is equal to 3x plus 2 is one-to-one. How does this work? So what we do is we usually use, like I mentioned, this latter definition. So we assume this, that f of x1 is equal to f of x2, and then we see if that logically implies x1 has got to be equal to x2. So first you plug in x1, and then you plug in x2, and you set them equal to each other. So we're going to have f at x1 equals f at x2, and this is what you're assuming. So logically, it's an if-then statement. So you're allowed to assume this part of the if statement, the if part of it, and then you want to see if this is the conclusion that follows. So you assume f of x1 equals f of x2. That is 3x1 plus 2 equals 3x2 plus 2. And what does that imply? Well, if you subtract 2 from both sides, you get 3x1 is equal to 3x2. And then if you divide both sides by 3, you get the logical conclusion that x1 had to be equal to x2. In other words, if you assumed the outputs were the same, that implies the inputs, the underlying inputs must have been the same. And that tells you the function, this function is one-to-one. So f is one-to-one. Okay, let's see an example of a function that's not one-to-one. So let's determine whether the function f of t equals t to the fourth plus 2 is one-to-one. So once again, you assume that the outputs f of t1 is equal to f at t2, and you're going to see what that implies about t1 and t2. So if you plug in t1, you get t1 raised to the fourth plus 2 is equal to t2 raised to the fourth plus 2. That's what we get when we plug in f at t2. So what does that imply? Well, if you subtract 2 from both sides, what you get is that t1 raised to the fourth must be equal to t2 raised to the fourth. Now, what does that imply about t1 and t2? Does it imply that they're equal? Not necessarily, right? Because one could be the negative of the other. The negative would cancel out. So all this implies is that t1 is equal to the positive or the negative of t2. Now, if you break that up, that's two statements, right? That's implying that either t1 is equal to t2. Let's write that. So the logical conclusion from that statement is that either t1 is equal to t2, and what that means is that if the outputs are the same, one option could have been that the inputs were the same, but another option could have been that t1 is equal to the negative of t2. In other words, just because the outputs are the same, you may have been in this situation where the outputs were the negatives of each other. And because this possibility arose, that means f is not one-to-one. In other words, just because the outputs were the same doesn't mean the inputs had to be the same. One could have been the negative of the other. And we can illustrate that with a specific example for this function. So for example, if you plug in f of 2, what do you get? Well, you get 2 to the fourth plus 2. and that's equal to 16 plus 2, which is 18. But if you plug in negative 2, watch what you get. You get negative 2 to the fourth plus 2, and that's also equal to 18. So in other words, both 2 and negative 2, they get mapped to the same value, 18, and that's why this function's not one-to-one, right? A one-to-one function never has two values mapped to the same output. In other words, with a one-to-one function, anytime the output, you know the input. That's not the case for this function. If you know the output is 18, you can't tell if it came from 2 or negative 2, and that's why this function's not one-to-one. Okay, until next time.